Hi, I'm Dr. Sam Williamson. I'm a senior lecturer in electrical engineering here at the University of Bristol. I've always been interested in Nepal. As a kid, I still remember looking at maps and books and finding out, it had 8 of the 10 highest mountains in the world. When the opportunity came to go to Nepal for a year, I took it. They didn't have the services that we had. They didn't have the electricity. They didn't have the access to things that we did. It really made me sort of value, I guess, a bit more what we had. I worked with a Nepali NGO in the end of my year in Nepal, so I worked with them for about 6 months, and we were working on small-scale hydropower systems. So hydropower is where you can use the falling of water to be able to generate power, and in this case, electricity. So you've got water coming down from a height quite often, and a large amount of water that can then impact or run over some blades, which then generate turning force, which you can then put onto an electrical generator and generate electricity for whatever's nearby. In Nepal, that's actually very useful for local communities, because to be able to extend the electrical power grid out to these communities is very, very expensive. But if you can generate your own power in a local place, really, really useful in Nepal. Previously, Nepali communities have used 2 types of turbines. One of them is called a cross-flow turbine, and one of them is called a Pelton turbine. Neither of these solutions were ideal. We'd been working on a different turbine type called the Turgo Turbine, but it hadn't been built locally in Nepal before.
We went and visited 8 of these small-scale micro hydropower manufacturing companies and conducted a survey where we were trying to understand what materials were available and generally how they approached the process of making turbines, to develop an understanding of what was possible, what we could do with the Turgo turbine.
There's obviously an immediate language barrier, but fortunately, we're very fortunate that we have this sort of communication through drawing and through maths. So here in the lab in Bristol, we were testing some small-scale turbines, and they were between 100 and 200 watts, not a lot of power. But then from that, we developed the scaled-up version of the design, and that went into a community in the far east of Nepal. And previously they had a cross-flow turbine there, and it was a bit old and battered. And when we installed the Turgo turbine to sort of renovate the system, we're generating up to about 31, 32 kilowatts from that. So over 50% of what the previous turbine was generating. You can cook with it a little bit maybe. You could charge your phones, you could watch TV, you could have some light during the day, during the evening.
In speaking to people, there was often this great sense of pride, and people felt very strongly that it was something that had come from a collective community effort.
So my PhD was about enabling electric cooking in rural areas of Nepal, and particularly looking at microhydro mini-grids. The problem is that almost everyone is still cooking with firewood, and they're spending a lot of time and effort collecting that firewood, and it has adverse health effects. One of the really key questions was, how much do people cook at the same time, and how much variety is there in their cooking practices? When there's not much spare power at peak times, little changes in when people start cooking across the community can have a big impact on the amount of cooking that can be feasibly done. On the social side, it's so important that people are trained carefully and sort of guided in their transition to a new cooking technology. If you just give someone a cooker, they won't know why or how to use it. And then on the technical side, what we found was that if you use more efficient cooking devices, insulated devices such as electric pressure cookers, that reduces the energy requirements and the power requirement of cooking, and therefore you can get more people cooking at the same time. So for electric cooking to actually be taken up and adopted on a widespread scale, there needs to be a lot of work on the repair and maintenance side of things and on supply chains.
I visited a site in eastern Nepal actually, in a village called Amjuk, and there was an old lady there. I asked her, what is the thing that you most enjoy about having electricity? And she said, the brightness. Having that ability to be able to do things in the evening, having that security as well. And that was the thing that she really valued most of all of the electricity. One of the great things about engineering is that we can work with all the other disciplines, so everything from sort of human geography and social science, with politics and economics, and try and bring things together. I'm really proud to be an engineer. I'm really proud to be able to be part of that solution and be able to work towards that solution. I love it.